Hi everyone, welcome back to Cody's Lab. So today I'm going to be making a liquid-fueled rocket. But before you get your hopes up, the fuels are going to be baking soda and vinegar. This is going to be something that's more like something that a young kid would build for a science fair. And today I'm going to be taking you through it. And you guys, if you have a science fair out there, you can use this project. I'm giving it to you. Just be sure to credit me and maybe watch through a few of the ads on my channel. Anyway, let's get started. So the first thing we need to do is make the baking soda, which is a solid, into a liquid. And to do that, I'm going to dissolve it in water. So I've obtained a 1-gallon jug here. I've wrote baking soda water on the side. And now I'm going to put this 1-pound box of baking soda into this jug. I might need a little bit of coaxing, but I'm sure you guys can figure this out. Okay, now that that's done and we've cleaned up any spills, we take this jug and we fill it with warm water. Not hot water, just warm to help the baking soda dissolve more easily. Okay, now that you've got your water in your jug, seal it up and give it a bit of a shake. And then release the pressure because sometimes baking soda does fizz when it gets in contact with warm water. Now I doubt all of it will dissolve, but the idea is to get as much dissolved in there as you can. So now the most important part of a rocket engine is the pumps. You see, you have to pump the fuel into the combustion chamber. And the more pressure and more volume that you can get into here, the more powerful the rocket. So I've got a bunch of these little 12-volt submersible fountain pumps. This is a brushless motor and it's completely sealed off from the water, which is good because we don't want anything shorting out. Now these were, I think $4 each on eBay, but yeah, it's just a little fountain pump. Now I've got 4 of them, and what I'm going to do is I'm going to put them together in series with the outlet of one going into the intake of the other. That way I generate more pressure. Now I could put a few more along the line, but at some point it just gets expensive buying pumps. So for this test I'm just going to do 2 pumps in line. You could do it with just one, but the idea is to build up as much pressure as possible. Oh, and that is 2 pumps for each of the liquids that I'm pumping, because I got to keep them separate until the time that they are being reacted in the reaction chamber. So I just need to cut a couple of pieces of this tubing here. This is 7/16 outside diameter plastic tube. I'm just going to stick this into the inlet of the one pump and on the outlet of the other. Just like this. And the same thing for the other 2. So now what's going to happen here is this pump is going to suck in some of the liquid, it's going to spin it up and pressurize it down this tube, and then this pump is going to take that, spin it up and pressurize it a little bit more. So now we can have this come off and into our pressure chamber. I'm going to mount everything on this skateboard, and hopefully we'll get enough thrust that the skateboard will move when we turn the rocket on. But I'm going to set everything up on here, that way we know how long we need to cut the tubes. So for the actual fuel tanks, I'm going to be using these 2-liter bottles here. That means I need to cut the tops off of them so that it'll be large enough to fit the pump down inside. You might want to get somebody to help you who's not prone to hurting themselves. You know, cutting things is rather dangerous, but compared to many things I do on this channel, this is rather tame. So I'm just going to duct tape these together and then duct tape them to the board. Alright, it doesn't have to look pretty, it's just got to stay on there. So now we want to insert the tube onto the outlet of the second pump. Now we're going to stick both of the pumps down into one of the fuel tanks. Make sure to keep the wires up and out of it. So put that in so that the first pump is nearly to the bottom of the tank. There we go. Just add a little bit of tape out here to hold the wires in place. And I take this tube down to where the combustion chamber is going to be and cut it to length. So there you go. Now we want to make 2 holes in the back of the bottle, which are just slightly smaller than the tube. The 7/16 outside diameter tube, I'm using a 3/8 inch spade bit. So we're just going to pick a couple of these knobs on the back of the bottle and drill the hole. Now hopefully we'll be able to force this tube into that hole just like that. Now I'm going to make one more over here. Now we just insert the tubes into this bottle and apply some fast drying adhesive, in this case shoe glue, to seal the holes. Now while that's curing, let's set up the power source for the pumps. In real life rocket engines, such as the space shuttle, they burn a small amount of the fuel together in order to produce the energy to run the pumps. This fuel, unfortunately, is not going to be energetic enough to provide enough power to run the pumps without burning all of it. Instead of doing that, I'm going to be using a different chemical reaction, a battery. Well, this is actually a capacitor, but battery will work just fine. It's just got to be 12 volts, enough to run these pumps. So now I'm going to hook all these wires together, black to black, red to red, and we're going to set it up so we can hook it to this capacitor here. Be sure to tape up all of these electrical connections so that they don't end up shorting out with each other. It'd be better to use actual electrical tape or perhaps even wire nuts, but this will work for my little demonstration. Alright, now when I touch this wire to this wire, the pumps come on. Now it might be a good idea to find a switch. I'll go look, but if I can't find one, I'll probably just twist these together when it's time to launch the rocket. Okay, we're ready to go. But first, let's fill it up with water so that we can be sure that it will work and to compare to the actual propellants. Alright, let's see how long it takes to pump this out. As you can see, there's really not a whole lot of thrust going on here. You can see the fuel's being consumed rather quickly. Now let's put the actual vinegar and baking soda in there. I'm actually going to add just a small amount of dish soap. That way we create a bunch of foam rather than just a spray of water. Alright, let's see what happens. Hooking the wire up in 3, 2, 1. Whoosh! It's a little more impressive, but you know what? I forgot something. We need a nozzle. So, this is just a nozzle that's off of a garden hose sprayer, and I'm just going to tape this onto the end of this bottle here. Now, yes, I know I'm using electrical tape for this, and I didn't use electrical tape for the actual electrical connections. Well, for this voltage it didn't really matter, and, well, I just now found my tape. Alright, so let me get this taped on here, and I think that's good to go. All we gotta do is fuel it and touch this wire together. Burn. Although, I don't really expect this to make much thrust. Hook it up. It wants to move. Not quite enough thrust. Let's see if we can figure out a way to boost that a little bit. I think perhaps one of the major problems we're having is the exit to this nozzle is a little too small. We need to widen that up a little bit. You see how it kind of sprays and then dies, sprays and then dies? That's because the pressure is backing up and stopping the pumps. Alright, so we're ready once again. Got my baking soda and vinegar. And I think I'm actually this time going to just spike the vinegar with a little bit of muriatic acid, just to increase the amount of acidity we got here, because I think we're not using up all of the baking soda. Okay, there's our muriatic spiked vinegar. It's loaded into the chamber. Now you'll notice the nozzle on this is quite a bit larger than the one I had before. In fact, the outlet has about twice the surface area of the inlets. Let's see what happens. So, picking up the pumps in 3, 2, 1. It's a little better. Looks like we're getting just a tiny amount of thrust. It is pushing it slowly. It's not quite enough to overcome friction, I'm afraid. And we're out of fuel. But it worked. How about that? Let's actually put it all the way over there. Oh, that moved. I actually felt that when I hooked it up. It actually made a little bit of thrust. How about that? Might have been better to do this like on a boat or something so there's less friction. Alright, so there it is, a liquid-fueled rocket engine. Just a model, a toy, but it shows many of the things that happen in real rockets. Most notably that we've discovered here is that the nozzle opening has to be larger than the inlets. Basically what's happening is we can only pump so much pressure, and the fuel, when it goes into the chamber, it expands. And the pressure is going out the same as we're going in, but the surface that it's pushing against is larger, so it creates a net force that actually creates a little bit of thrust. How cool is that? So there's a lot of things you could use with this design. You can test the different types of materials, like does spiking it with the muriatic acid really increase the amount of force because increase the reaction. You know, you can play with the temperatures, all sorts of things you can do with this. There's another run with just water with the new nozzle, so you can see. Yeah. Okay, time for the explanation. So the two liquids, the baking soda water and vinegar, come through these two tubes here, and they go into this glass reaction chamber, and when they combine, the two liquids react to form sodium acetate, water, and CO2. The CO2, of course, is what is forming the bubbles and is causing the fuel to increase in volume and the pressure in here to increase. And in an ordinary rocket, this would be a reaction between liquid oxygen and a combustible fuel, which produces high temperature gases as a byproduct. But this has the same basic principle here. So let me turn this on so you can see it a little bit better. As you can see, the liquids are reacting and forming lots of CO2 bubbles. Those, along with the leftover liquid, are being shoved out with a little bit of speed. So this is actually the second time I've built a model liquid-fueled rocket motor using the alkali and acid fuels. This time I used centrifugal pumps, but the first time I did this I actually used a air compressor to pressurize the bottles and pressurize the fuel. It does the same thing. In fact, that worked a little bit better. I'll put a link in the description as well as a clip on screen here. Anyway, like I said, this would probably make a pretty good science fair project, but really not very interesting other than that. You know, maybe you could play around with the nozzle and do different things, you know, measure different forces and write a pretty interesting report on it. Now, I plan to be working with some more energetic materials, liquid oxygen and stuff, but I think this is a good little starting point. Anyway, hope y'all enjoyed. I'll see you next time.